Namaste. Welcome to Pythagoras Academy. In this video, we'll try to understand the concept of apparent weight. Most of the students are confused between mass and weight. When you stand on a weighing machine to check your weight is a term we regularly use in our real life. So it shows a reading like 60 kg or 70 kg. So that 60 or 70 kg is your mass but not weight. Weight is the force exerted by the earth on any mass. So this is earth. When we are on the surface of the earth is exerting some force which is g(m) by r square. This g(m) by r square is constant, which is termed as acceleration due to gravity. So mg is the weight of the mass m. So the 60 kg or 70 kg that reads in your weighing machine is not your weight but mass. So mass into acceleration due to gravity, whose value is approximately equal to 10 meter per second square, gives you the weight, which is the force applied by the earth on the mass or on you. So if your mass is 60 kg, your weight is 600 Newton. Because weight is force, obviously the units of weight would be Newton. Now what is apparent weight? Suppose you are standing on a weighing machine and it reads 60 kg. It's like this. Consider an elevator whose acceleration is 0. Or consider a room, there is a weighing machine and you stand on the weighing machine. There is no acceleration to the weighing machine and it reads 60 kg. So your mass is 60 kg and your weight, your true weight is 600 Newton. The same weighing machine, so if you draw the free body diagram here for the mass, say a man is standing on the weighing machine. So imagine there is a weighing machine here. So there is mg, a normal force applied by the weighing machine because he is standing on the weighing machine. Acceleration is 0. So n minus mg is 0. N is equal to mg. Mg is your true weight. If your mass is m units, for example 60 kg, then it is fixed. If you go to moon or if you go to some other planet or if you are on earth's surface, your mass is just 60 kg. But what varies is your weight. Weight on earth is 60 into 10, 600 Newton. Weight on moon is 60 into g dash, acceleration due to gravity of the moon. Weight on some other planet is mass into acceleration due to gravity due to that particular planet. So your weight can vary from planet to planet, but your mass remains constant. Now, when you are standing on a weighing machine, the weighing machine has no access to measure the force applied by earth on you, because mg is a force applied by earth on you, and weighing machine has absolutely no access to gauge this particular value mg. What actually the weighing machine can measure is the normal force. Because you are standing on the weighing machine, you apply some normal force on the machine. The machine is exerting back a normal force on you, which is normal reaction in the upward direction, which is n. All that a weighing machine can measure is this value n. So this n is known as apparent weight. In this case, if the elevator is at rest, or if you are simply standing on a weighing machine which is placed on the ground at rest, in that case n happen to be equal to mg. Apparently the weight measured by the weighing machine is equal to your true weight. So I can say that in this case apparent weight is equal to true weight. So you are getting here the exact readings of your mass. Now take this example. There is an elevator and you are standing on a weighing machine inside an elevator which is going up with an acceleration a. So you can work either from ground frame of reference or you can work from elevator frame of reference. If you are working from ground frame of reference, it is an inertial frame of reference, and if you are working from elevator frame of reference, it would be non-inertial frame of reference because it has got acceleration a. Now the forces acting on this man are his own weight mg, and he is standing on the machine. The machine is exerting a force n in the upward direction. If you observe from the ground, there is acceleration a, and I can write n minus mg is equal to ma. So n is equal to m into g plus a. the readings of the weighing machine now will be more than your true weight, because n is reading m into g plus acceleration of the elevator. Suppose the readings of the weighing machine when you place it on the ground is 60 kg, now it will be more than 60 kg, for example 65 or 64, whatever it is. I can say that true weight or the apparent weight in this particular case is greater than true weight. True weight is mg. Apparently the reading that you check on the weighing machine, which is placed inside an elevator, which is going up with an acceleration a, is m into g plus a, more than true weight. Now let us also look at the same concept here. In this case, elevator is coming down with an acceleration a. So mg down, normal force applied by the weighing machine up, and the acceleration of the man as seen from the ground is a down. So net force is mg minus n, that is equal to m into a. Net force is mg minus n. So n is equal to m into g minus a. So the direction of acceleration, if you take positive, it is like mg is more than n. So the net force is mg minus n. That is the resultant force acting on m, which is equal to mass into acceleration. And the value of n, that is now m into g minus a. Apparently, the readings of the weighing machine will be lesser than the actual value, or lesser than the reading that you could see when you are standing on the ground or when the weighing machine is on the ground. So I can say that apparent weight is less than true weight in this particular case. So this is the concept of apparent weight. Apparent weight is the reading that a weighing machine or a spring balance is giving you. Just like the weighing machine can read the normal force, a spring balance will read the spring force. For example, if you are connecting a block of mass M to the spring, this is the spring balance, for example. So there is weight mg down and spring force kx up. If this spring balance is placed to a ceiling, or if it is on ground, then acceleration of this mass is 0, so kx is equal to mg. So kx is the apparent weight that is read by the spring balance, which is actually equal to true weight. Now if you place this spring balance setup inside an elevator which is moving up with an acceleration a, or inside an elevator which is coming down with an acceleration a, same thing you can observe. Instead of n, you will have kx. That is the only difference. Alright. And now if you observe this case, the elevator is descending with an acceleration a. By any chance, let us take this example. By any chance, if a is equal to g, if the acceleration of the elevator equals to the acceleration due to gravity, it's like the elevator is experiencing free fall. Only for a freely falling body, the acceleration experienced by it will be equal to g, isn't it? It's like the cables of this elevator are cut and the elevator is experiencing free fall. A is equal to g. In that case, what is n? N is equal to m into g minus g, which is 0. N is 0. So normal force is 0. What does it mean? The man who is standing on the floor of an elevator is losing contact with the elevator. There is no contact force. Now the man and elevator are moving like independent bodies. They are experiencing free fall. Not only this, if acceleration is greater than g, for example, a is equal to 12 meter per second square. In that case, what is the value of n that you get? So if a is equal to 12 meter per second square, the apparent weight is m into 10 minus 12, that is minus 2m. N is negative. The meaning of normal force being negative is normal force acting in the opposite direction, which is not possible. Whenever you get the value of normal force 0 or negative, it means that there is no normal force acting on it, because normal force cannot be a pulling force. Normal force is always a pushing force. The surface of the elevator or the weighing machine can only push the man up. So normal force will be either upwards or 0. So normal force is negative. The conclusion is that there is no contact between the man and the elevator. So if the elevator is descending with an acceleration greater than or equal to g, then apparent weight is 0, or there is no contact between the elevator and the man will feel that weightlessness. The feeling of weightlessness does not mean weight has disappeared. Weight is always there. When we stand on the ground, we feel our weight. The feeling of weight, the sensation of weight that we experience is because of the normal force. So we are actually feeling the sensation of this normal force. If there is no normal force, suppose if you're jumping from a building, there is no normal force, so you don't feel the sensation of your weight, so you feel that weightlessness. So weightlessness is not weight disappearing. Weightlessness is just that there is no normal force acting on you to make you feel your weight. That is the only difference. So this is all about the apparent weight. Thank you so much.